Yes.
Yeah, this is our recent collaboration with Populous, collaboration between EmTech and Populous. Basically create self-standing structures with very much lightweight and flexible materials.
It's the conclusion of a year-long research project. We started experimenting with rattan canes. First understanding the material behavior through small-scale physical prototyping to large-scale build-up pavilions, which started with last year in the format of the workshop we run called DLab. The process was very iterative, as what we also teach our students in EmTech through digital prototyping, physical prototyping, understanding the material behavior, both through simulations and the physical tests. And this is the culmination of this research that took a year to understand and perfect this workflow.
We are relying on friction between the rattan canes. So that means we are not using any adhesives between the canes, and we are relying on that friction to create that composite material. There's a limit to how much humans can twist. We want to have precise control on how many mutations we could have with the robots until the material starts to fail.
This current version of the pavilion is being built and fabricated, led by our phase 2 students, a cohort that started last year, 23-24, and our current year cohort, 24-25. We're also helping them, but we also need to give credit to our DLab students that we did this research, started this research with last year, and last August we experimented with different ways of building a structure with this material. So it's quite a handful of students. I could say around like 40-50 students along in span of a year and a half.
Of course, it's very much about understanding the material behavior, so a lot of physical prototyping, a lot of material modeling tests to understand the mechanical properties of the material, such as its Young's modulus, various directions, and then calibrating our computational models in relation to what we understand from those physical experiments. So it's very much iterative, and it's an ongoing process, really.
Collaborating with Elif and Milad and their students on the DensiFlora Pavilion has been a great and a very rewarding experience for us in Populous. It has been really amazing to watch the students bring to life this cutting-edge material research that is paired with advanced computational design and robotic fabrication and really sustainability focused. On our side, this project has been a great opportunity to bring together so many talented teams in Populous. Our experienced studios worked on creating an audiovisual activation of the pavilion. Our global digital team focused on creating this immersive experience in the digital twin within the RAF, and our Encapture Studios crafted the story narrative of the pavilion and this collaboration. The result is a perfect example of how we can blend physical and digital worlds into creating something that is unique and engaging. This collaboration reflects our commitment in Populous to pushing the boundaries for design and innovation, and we are really proud to have collaborated with the AEA on this endeavor, and we're looking forward to see what this might bring in the future.
So we've been adding the kind of audio-visual and interactive elements to this, as you can see and hear behind us now. So we've worked on an interactive lighting sculpture element to it. So you can actually interact with the piece, and we're having lighting and soundscapes triggered by contact mics. So 6 contact mics that are positioned on the fabric of the sculpture. So it almost acts like an instrument. So everyone's having fun here and playing sculpture. And it's sounding beautiful. We've got a soundscape composed by Wawa Sang, and yeah, hope everyone's enjoying the event.
Learned a lot about the material they're using, and we were able to record how they bend the rattan with the robots, which inspired a lot of the sounds able.
Well, it's always a great moment when like a lot of effort has gone into a project, and then you end up seeing it come alive, and like it's usually a last minute moment, you know. There's always little bits that you have to fix before it comes up, but we usually manage to have it up in time, and then it just works out at the end.
Whatever we were doing in the competition is affecting what we are building up in the site, and what we are doing in the site is affecting the competition again, and the fabrication of that, the 3D printing, the robotic computation, everything. So it's all connected basically.
To start with, the material was very new to us. None of us had experienced this material, and to test it and come out on the results, and then there was a constant feedback from computation to physical. A lot of lessons that come out of it that will obviously better our next projects, you know.
And the best part being just to enjoy it at the end.
What do you think of it? It's cute.